Okay, so what we'll talk about today is what the blockchain is and why it matters for enterprise computing. So unless you've been frozen in carbonite, you're probably familiar with what blockchain is. And it basically gives us a way of being able to communicate and collaborate in distributed, decentralized environments. And the presentation will first talk about the need for digital asset management, which is at the heart of some of the topics we'll discuss. I'll then give an overview of blockchain and show why it matters for enterprise companies as opposed to the more generic use as the basis for cryptocurrency, which is another way to do things. And then I'll also explain some of the technical foundations of blockchains, focusing on something called Consortium Blockchains, which I think are particularly relevant for the project that we're trying to do. So let's start off by talking about digital asset management. So what's a digital asset? A digital asset is basically anything that exists in a binary format and comes with some rights to use. Some digital assets are so-called native assets. These are things that fundamentally lack a physical substance that can be owned or controlled and produce value. So digital music, images, movies, documents, electronic funds, software, those are all examples of native assets. There are also digital representations of more traditional assets. So these would be things where we have a digital form for something that, at least historically, used to be represented on paper certificates or titles, things like land, property, gold, automobiles, stock, currency, and so on. Hopefully it's pretty clear that our economy increasingly depends on the effective management of these digital assets. So entertainment, obviously movies, digital rights management, finance, moving funds around, electronic fund transfer, the energy sector, defense, cybersecurity, for example, people trying to do online elections. Obviously, this is very important, managing your vote. You only get one vote per person. It should be your vote. Your reputation in social networks. Can someone hijack your social network account and do scurrilous things that get you in trouble and so on? There are a number of common operations on digital assets. There are a bunch of things you can do with them, and this gets into sort of the project that we're working on. One of the classic things you can do with a digital asset is move them around online in some type of transaction where things either occur as one unit or don't occur at all. So recording and transferring digital assets between senders and receivers, moving money around between bank accounts would be one example, or doing some kind of electronic funds payment for your credit card would be another example. Something that's a little closer to what we do in our work is digital identity management. So there's an interesting article here at the bottom by Accenture about digital identity in a modern world. And the point of the article is that there's a lot of people on the planet who don't have the luxury of a passport or a driver's license or some other way to identify who they are. These are people like refugees, for example. And they've developed an interesting approach that will take biometric information and then be able to track that person's digital identity and then make sure that people can't show up in multiple places and try to spoof a relief agency or spoof border control or other kinds of things. So digital identity management is another example of something you could do with a digital asset that's related to a real asset like you. Another really interesting topic, and I strongly recommend you take a look at the link at the bottom by this company called provenance.org, because they have some really cool case studies. It's called provenance tracking, which is basically a way to provide a digital history for physical products such as supplies or components or food or other kinds of components you would use to make a bigger product in order to trace and verify their origins, attributes, and ownership. So think about things like, say, blood diamonds, or think about organic food, or think about some kind of sustainable ecosystem where you want to be able to track where the things come from in order to be able to feel good about the end result as having some kind of social good. So that's what's often called provenance tracking. Yet another topic, which is also very related to what we're working on, are so-called third-party data attestations, where you can have some entity make a claim that can be verified later. So you might have somebody say, I graduated from Vanderbilt University, or I graduated from University of California, Irvine, or whatnot. And someone might want to go back for your employment history or some kind of check if you join a company. They want to verify that that's actually true. Can someone show that you did that? How can you attest to something? So criminal records, former employees, schools, etc. There's lots of things where you want to be able to attest that something took place, and you want to be able to record it. And this might be, digital signatures on documents, what's the latest version of a document, all those kinds of things. So that's another set of things you might want to do with digital assets. So how are these assets traditionally managed? Well, historically, these assets have been managed by centralized and proprietary brokers. And these brokers serve as trusted intermediaries between buyers and sellers. Examples include things like financial institutions, who obviously move money around, credit agencies that keep track of what your credit ratings are and your expenses and whether you're living beyond your means and whether you miss payments, those kinds of things. Electronic medical records that keep track of your health and your medical history. And then something else that's perhaps more related to some of the research we do at Vanderbilt, energy transactions in a microgrid, keeping track of who's buying and selling energy between prosumers, producers and consumers of energy, because you might have some kind of sustainable solar power or wind power, and you want to be able to trade that with people in your neighborhood or in your region. Well, those are all things that are historically done with traditional digital asset management mechanisms that are centralized, but there's some limitations with this approach. Here are some of the limitations. First of all, centralized approaches are often insecure. You don't have to go looking very far to see numerous examples of data breaches of centralized data brokers in recent years. So the Equifax hack that affected about half the country and had people stealing credit history and credit information that's very valuable. We'll be dealing with that for the rest of our lives. The OPM, the Office of Personnel Management, there was a breach of security clearances that caused a lot of problems for people working in the defense and intelligence agencies. Huge problem. Whenever you start putting stuff in a central location, it's just inviting people to come along and attack it. Another problem with centralized approaches is they're expensive. The brokers take their cut, so they increase the cost to the providers and the consumers because they shave off 3% or whatever the transaction fee might be, and which could become large over time, especially if you do a lot of small transactions. Another problem with centralized approaches is they're vulnerable to abuse. Whenever you centralize something, it concentrates a great degree of power, wealth, and control in a small number of institutions, which is, of course, good and bad. This is a blessing and a curse. So one nice thing about centralized control is that there's typically one place you go if you want to fix things. So, for example, if there's a problem with your bank or your credit card company has accepted fraudulent charges done by somebody who stole your card, you can go to one place typically and get that fixed. The downside is that unscrupulous people, administrators, insiders, hackers, whatever, can come along and attack those centralized resources and change your financial history in ways that may be very detrimental. So where that's all leading, of course, is to the fact that blockchain technologies are designed to more effectively manage digital assets by disintermediating these centralized brokers. So what's a blockchain? So a blockchain is basically a decentralized platform that supports so-called trustless transactions. And they're used for various things. They're most famously used as the computational substrate for cryptocurrencies such as Bitcoin or Ether or Litecoin, and there's dozens of these things now. But they're also useful for a lot more other things, and that's what we're really going to focus on. A cryptocurrency, as you probably know, is simply a digital asset that uses cryptography to secure transactions, control the creation of units, and verify transfer of assets between parties. So a blockchain, as the name suggests, is a chain of blocks. And these blocks are a continuously growing list of records that are linked and secured using cryptography. And basically what this chain of blocks does is it provides an open and distributed ledger that immutably records transactions between two parties efficiently and verifiably. I put the word immutably in quotes for a reason, because even though we like to pretend like it's immutable, there are ways to change these things. And if you take a look at the link at the bottom of the page, it'll give you some scenarios under which blockchains can be changed. records in a blockchain or blocks in a blockchain can be changed. At this point, it's unlikely, but you have to be prepared for it. The blocks themselves contain a bunch of transaction data. These are things, for example, in a Bitcoin blockchain that would keep track of who's spending and who's receiving the Bitcoin assets that are being transferred between the various parties. So a given block contains a bunch of transactions of that form, and the blocks, we have blocks of transactions that are grouped together to enhance performance because we can pass them around in a bigger chunk. They also contain a timestamp and something called a hash pointer that is a link to the previous block, and all these links together form the blockchain. And the reason why we keep hash pointers is because it makes it easier to tell if someone has tried to tamper with the blockchain. So rather than storing just like a number, like the previous one is number 72, that would make it easy to make the changes. These blocks are replicated across potentially many computers rather than being stored in a single central server. And therein lies part of the power of the blockchain. And we'll come back and talk about that later. Sometimes blockchains are distributed globally, and we typically call these things public blockchains. Public blockchains get safety in numbers, and we'll talk a bit more about how we have consensus and how we try to avoid various kinds of attacks and so on. But the basic idea is as long as you have more than, if you have a majority of people who have a certain view of the blockchain's contents, then it makes it difficult to change it. Public blockchains are not very efficient. We'll talk more about their inefficiencies later, but they're very useful if you don't trust all the parties. So if you don't know who's involved, if you don't trust who's involved, but you have lots of parties involved, then public blockchains are a way to go to get this approach to giving trust. You can also localize the entities that are part of the blockchain to a limited group, which is sometimes called a consortium blockchain or a private blockchain. Those terms have slightly different meanings. For the purposes of what we're talking about now, I'll be using the word consortium blockchain, and I will also talk a bit about private blockchains as well. Consortium blockchains, by their very nature, are limited to a smaller group of participants. So they're permission. Not everybody can join, not everybody can read, not everybody can write. You keep track of those things, and you only allow people with access privileges to be part of the group or the consortium. So that allows them to be more efficient, but it also means that you have to assume that participants are relatively trustworthy. Now, if people decide to collude or if people decide to abuse the system or if mistakes get made, there are ways around that, but those ways are typically through legal means by going to court and then showing people the provenance of the transactions to show that someone made either accidental or malicious modification to the state of the records. So even with a consortium blockchain, they're vulnerable to attack, but there are ways around that. And it's typically, as we'll see shortly, easier to figure out what's going on. In either case, the nodes in a blockchain, be they consortium or public, have a high degree of independence of control and processing in a peer-to-peer network or internetwork of collaborating nodes. And in a blockchain, every node in the blockchain, each of the computers or the resources that are available, run some common middleware, and that middleware runs on top of the underlying operating systems and hardware. So there's nothing too revolutionary about this. People have been building these kinds of distributed systems for a long time. And all the nodes have equal level of privilege and access. Here's a kind of a zoom in on this. So this is an example of some of the services you might have provided by a blockchain middleware provider, such as, say, Hyperledger from IBM or Ethereum. And some of the services include consensus managers. We'll talk more about consensus shortly. Something to keep track of the distributed records, the distributed ledger, some kind of protocol for communicating back and forth and doing notifications, some place to store the data or some means to store the data, ways of being able to keep track of who can access the system, who has the privileges or the authentication to join and be members, ways of being able to audit stuff in case you have regulators who want to keep track of what's been going on. So those are some of the things that you could have provided by your blockchain middleware as services that the applications can use above and beyond what comes out of the box with the operating systems and communication protocols. So that's the decentralized platform portion. The last piece of the definition are the trustless transactions. And what this means is that you can use this blockchain middleware to exchange digital assets anonymously without the need for some central authority to verify what's going on and to transfer the valuable artifacts or the valuable assets from one place to another. And in fact, this stuff runs right on top of the traditional internet, which uses classic protocols like TCP/IP to store and copy data throughout the system. The word trustless is kind of funny, and I got a little meme generator for, I think his name was Iago from The Princess Bride, where he's always saying, inconceivable, I do not think that word means what you think it means. Well, in this context, trustless is kind of a funny word. It just means that the ability to trust something doesn't depend on the intentions of any particular party, which could be arbitrarily malicious. So we don't really assume any given party in the blockchain is trustworthy. So together, it's safety in numbers, and if we have enough parties involved, then if we incentivize them properly, we'll get a trustless infrastructure that is trustworthy, which is kind of funny. Key thing to remember here when we talk about trust and blockchains is that blockchain technologies are most useful when the benefits of disintermediation, in other words, cutting out the centralized broker, are more important than maintaining strict confidentiality. As we'll see shortly, one of the downsides with the blockchain is you typically give up privacy. Even if you have anonymity, you give up privacy, and so people could figure out through some kind of traffic analysis what's actually taking place, and that is actually problematic, and I'll talk later about why that's a big deal and what you can do about it. First, though, here are some of the key characteristics and benefits of a blockchain, and for most of this discussion, I'll be talking about blockchains in a general sense, which include both public and the more consortium or permissioned or private blockchains. Blockchains integrate several different areas of study: computer science, mathematics, and economics. From mathematics, we get cryptography, we get hashing and authentication and assurance and non-repudiation, so we can keep track of what's happening and make sure the right things happen and people can't impersonate each other and unless they do things like steal private keys and so on. From distributed systems, we get the concept of fault tolerance, having the system be able to provide coherent behavior even in the case of accidental or malicious faults up to a certain number. And we also have a way of being able to keep track of what happens and when without requiring all the computers to have completely synchronized clocks. And then from economics, we get the concept of incentivization and trying to get people to work together and do the right thing even though we don't trust each other very much. So we'll talk a little bit about that. That's kind of from game theory. There's several key characteristics and benefits of a blockchain. Probably first and foremost is this concept of a consensus protocol. And consensus in this case simply means, will everybody eventually agree that certain transactions took place? Will they agree who the parties were? Will they agree what was exchanged? And will this eventually lead to something that's an agreement? And what you're trying to do through this consensus protocol is avoid the situation where a small number of bad actors or traders cause the system to do malicious or incorrect things. And there's a classic problem in distributed computing called the Byzantine generals agreement problem. And it basically has to do with how many traitorous generals can you endure until you get a system that no longer can behave in a consistent and coherent way. And if you do this properly, then everybody will agree or not agree to do something. If you do this improperly, then certain traitors can cause the system to behave in unpredictable and unexpected and problematic ways. The way this works in many blockchains at a high level is to ensure that the blocks are ordered in some common and unambiguous way, and this may take place literally across the entire world. That's the way the public blockchains like Bitcoin or Ethereum work. And so eventually, this may take a while, may take 10 minutes or longer, eventually you'll end up with agreement among all the different parties that some transactions have taken place all around the world, or whatever your group of platform providers and interested parties are going to agree on. In the Bitcoin blockchain, this consensus protocol is facilitated by and enabled by something called proof of work. And this is basically the insight that the concept of proof of work has been around for a while, but the insight that was provided to make the Bitcoin protocol was you give all the participants some pointless but expensive computation to carry out, and then they compete to solve that expensive computation first. And it takes a while for them to do it, so they have to put some skin in the game. And whoever finishes first is given a reward in the cryptocurrency monetary unit of whatever you're doing. In this case, it would be Bitcoin. So you give someone some Bitcoin if they finish first. And so that incentivizes people to do the right thing. And ideally, you want to incentivize at least a majority of the nodes to do the right thing. Some nodes could collude, some nodes could have mistakes, but the majority of the nodes, as long as the majority of the nodes do the right thing, then you're going to get a consistent result over time. It's interesting that the origins of the Bitcoin blockchain protocol are somewhat shrouded in mystery. So if you take a look at this link, you'll find out that people still don't really know who the person is or the people are who invented the Bitcoin blockchain protocol, although they think they've identified a particular person as having done it based on content analysis of their writing style and their comments in the code. So really fascinating story to take a look at. Totally irrelevant for what we're discussing here, but interesting. Another characteristic and a benefit of a blockchain is this immutable replicated database. And in this context, immutable simply means something that is unchanging over time or is unable to be changed. So I always think about Julius Caesar from the classic William Shakespeare play where he says, "I am as constant as the North Star, for always I am Caesar." So once he made up his mind, he wouldn't change it until he was stabbed to death, of course, in the Forum. How this is done in a blockchain is by using a distributed ledger that contains time-stamped info for all the blocks that are replicated on all the servers. So again, at least in theory, once the data jogs in, it's like a roach motel. It doesn't jog back out again. It's stuck immutably where it once the consensus is reached. And it's hard, though not impossible, to change a blockchain without a fairly large amount of collusion. If you take a look at the link at the bottom of the page, you can find out some of the theory behind what you would have to do to change a blockchain. And it's certainly possible. And if you had big enough actors like nation states that decided they wanted to do this, they could. But even if they were able to do that, it wouldn't be hard to detect that someone had changed the blockchain because all the other data is replicated around the world. And if people were interested in looking for collusion, they could certainly find it. Now, how the heck you would remedy it in a public blockchain is one thing. In a consortium blockchain, the answer is a lot easier, and we'll talk about that. Something else you can do with a blockchain, at least in theory, is not unlike what you can do with a reputation system, such as what we have with Amazon or eBay, where you can have identities, and even though you may not necessarily know the identity of the person, you can know their behaviors. You can know whether they are honoring their agreements. Do they give you what you expect? If they ship you something, does it show up? Is it on time? Is it working? And so on. And so in the world of digital asset transfer, you can use this to build a sense of trust among otherwise anonymous users of online communities. And that's one of the motivations for people who look at this as a transformational capability to change the world of the financial system. Although, as we'll see, that's not as important for what we're trying to do. So speaking of what we're trying to do, why the heck does any of this stuff matter for enterprise companies? So it turns out that blockchain can be useful to help address certain needs in various enterprise domains by providing a decentralized transactions as a service model. So transactions become something that you can get as a service, and if you set things up properly, then those things should sort of just work, and if they don't work, you can find out why they don't work. So when done well, blockchain can save a lot of hassle, potentially, and potentially a lot of cost by disintermediating these centralized brokers while still allowing multiple non-trusting parties to share a common database. So we move from sort of this centralized model with, the Federal Reserve Board or Bank of America or Royal Bank of Scotland or whatnot, or the SWIFT system that transfers money around between banks. We move from that world of today to something where we have many parties working together through a shared ledger, and they have a common database, and yet they don't really trust each other. As I mentioned before, blockchain technologies work best for certain types of apps and certain types of domains. They work well when disintermediation is more important than confidentiality, and they work well when generalized robustness, in other words, no single point of failure, no single point of attack, is more important than raw transaction throughput and performance. And if you take a look at the link at the bottom of the page, there's a great article by Gideon Greenspan where he talks about all these different kinds of things. Here are some of the domains that blockchain works well at. So one approach is what we call lightweight financial systems. So an example would be refugee aid centers. For example, the United Nations provides thousands or tens of thousands of Syrian refugees in Jordan with food, clothing, and other aid in a very cost-effective manner. And it doesn't require the UN to be beholden to any given national or multinational financial institution like Bank of America or Royal Bank of Scotland and so on. And so it's also easy to track, easy to audit, makes it hard for people to use their aid for things like buying drugs or guns or alcohol. They can, sort of use it to buy the stuff that they're able to buy because they're sort of like EBT points or frequent flyer miles. Another example of something that we're actually working on here at Vanderbilt with Professor Abhishek Dubey is the area of smart cities. So we've built a cool transit app that you can use for multimodal transit around Nashville, and you can imagine setting this up to use some kind of cryptocurrency tokens where you could pay for your rides without having to have necessarily your credit card connected directly to this thing. And you could use it sort of like bus tokens or some other kind of fare card. If you've ever been in Washington, D.C. and ridden the metro, they have fare cards. You could have sort of a virtual fare card that would be useful in this environment. Another area that we're doing some work in is in the area of smart grids, so making it easy to transfer energy between producers and consumers in sustainable energy grids, such as solar power communities with solar panels on the roofs, or a wind farm in a region that supplies a group of neighborhoods together, and they can actually kind of trade energy back and forth off the grid, if you will, and they can keep track of this for accounting purposes. It's interesting to note, by the way, that in both of those cases, at first glance, it seems like these are ideal uses for blockchain because you're really trying to disintermediate things, and you may not care that much about confidentiality. What would be known is that a certain person might be traveling at a certain time, or certain people might be using power at certain times. You might not necessarily know who those people are, but you know their usages. So if that's a problem, you have to do some other things through techniques such as homomorphic encryption or zero-knowledge proofs in order to shield and shroud that knowledge even further. And blockchain technology is still kind of in its infancy in those areas. But these are some places that are relevant. Here's some other use cases which are even more related to what we're doing. So this is in the context of interorganizational record keeping. So finding ways to provide patients or their surrogates with better access and control over their health information, which today is scattered all around different healthcare providers, and it's very complicated and expensive and cumbersome to get access to it. With a blockchain-like model, you could make it possible to grant access or get access to this information, which itself wouldn't reside in the chain, but the access to the information or the information about the metadata of where to find the information could very well be represented in the blockchain. Another example that's close to home is supplier risk management that allows third parties to attest to certain attributes of company profiles in a trusted manner. And as you know, there's a variety of work from Accenture looking at these topics, and basically it's all about trying to keep track of these documents and then have a way of being able to go back and say, was this actually the accurate representation of the company's finances at this point in time? Is this the latest copy? Is this the right copy? And you have a way of being able to access that information and use it for decision making without necessarily storing the information on the blockchain itself. You just store the metadata. So what are the limitations with blockchains for enterprise companies, and how can we work around them? Well, it turns out that for certain types of apps and domains, blockchain doesn't really work very well yet. And other technologies, such as more traditional centralized databases, work better. So in areas where confidentiality and performance are paramount, that's one good example. Ironically, one of the original motivations for having blockchain was to be able to replace the financial sector. People wanted to get rid of central banks. They wanted to get rid of the banking industry. And they would instead use these on-chain tokens like Bitcoin to represent cash, stock, bonds, titles, assets, whatever. And so that was a big motivator, maybe 2 or 3 years ago when people started really getting all excited about this. It turns out in practice, this is not likely to happen anytime soon. And the main reason for that is that blockchain just doesn't give you enough confidentiality in its current incarnation. The Bitcoin blockchain leaks way too much information, and big enterprises, financial services, companies don't always want everybody to know what's being transferred back and forth. For example, if you were the CEO of Fusion GPS, you probably didn't want people to know who was buying and selling the information you were getting from the Fusion GPS company. Well, of course, that's now come out, but that came out because of a subpoena, not because somebody went through and reverse engineered the blockchain transactions to figure out what had happened. Moreover, public blockchains are poorly suited for enterprise companies in a number of ways. For example, one of the problems with public blockchains, such as the Bitcoin blockchain, is their low transaction capacity. The transaction capacity of Visa in terms of transactions per second is something like, say, 24,000 transactions per second. And they could probably increase that if they threw more processing at the problem. Conversely, Bitcoin's maximum capacity is about 3 to 7 transactions per second. And this is not 1,000 transactions per second. This is transactions per second. So it's way, way, way lower, as you can see. And this is due to a variety of things. It's the limit on the block size, and there's a whole bunch of discussion about how to fix this problem. But right now, this is a big problem. We're not going to be replacing credit cards with blockchain and Bitcoin anytime soon, public blockchains, because they're just way too slow. Another big problem that tend to make enterprise companies nervous, especially banks, but not just banks, is the questionable governance of the cryptocurrency ecosystem and the fact that a lot of the miners, especially the predominant place where the miners are doing their mining and verification, come from places in the world that don't always have a good track record with respect to being, business friendly and respecting intellectual property and not trying to take over the world. So there's a lot of nervousness about betting everything on people in, Lower Slobovia or Albonia where they're doing all this work and we don't really know who they are. And either the government could come in and take over and do malicious things, or the government could come in with a bunch of tanks and destroy the data center one day and knock, a huge capacity off the network altogether. Another problem that we have these days, and it's interesting to take a look recently, this has really become a problem, is the fluctuating transaction costs. Right now, it's getting to the point where it's costing, $20 to $28 per transaction in order to be able to do the verification by the miners. Well, that makes it pretty pointless to use Bitcoin for things that are not giant amounts of money, right? If you're going to buy a car, then $28 is no big deal. If you're trying to buy a pack of gum or a pack of cigarettes or whatnot, that's wildly expensive. So it means you really can't use these cryptocurrencies for transaction costs. You can't use public blockchains for fine-grained transactions. And a lot of people are just nervous with cryptocurrencies in general. If you haven't noticed, they tend to spike in terms of value. I think today they lost, thousands of dollars off the price of Bitcoin. Tomorrow it'll probably double, but it's very, very volatile. Another thing that makes people very nervous about public blockchains is that anybody can write and everything that's written is visible. At least the metadata parts are visible. So someone's always watching the bits go back and forth. And here's a nice little diagram that sort of illustrates the concern here. So this kind of graphs anonymity from less to more in the x-axis and privacy from less to more on the y-axis. And you can see certain things are very private and very anonymous. Anytime you want to pay with cash, for example, unless you're paying with marked bills or whatnot, it's very hard to trace because those are what are called bearer assets, which is why they're often used for things like money laundering. At the other end of the spectrum, you have things like large campaign contributions where people have to release who they are and everybody can find out who's contributing large amounts of money. So if you want to find out what the Koch brothers are up to, you can find that out. Other things where you have privacy but not anonymity would be public charitable gifts. If you ever go to like a museum, you'll often see the list of donors, but they often don't say how much they contributed. So some information is private, but the fact that they contributed might be public. Credit card and debit cards are somewhat private, but if anybody really wants to find out the information, they can go subpoena your bank, or they can go steal your bank records or whatnot, and they can find it out. Bitcoin, as you can see, is anonymous because it's only using public keys to keep track of identity, but the information about what's happening and who's transacting with whom, all the metadata, is all open. So it's not that private. So you have to be aware of that if you want to use this stuff. And another problem that we often don't think about, but is becoming a big problem for blockchain in the Bitcoin environment, is that they have a single, absolutely bloated ledger, which just has all kinds of crap dumped into it. There's like, pornography, there's all kinds of strange things people have embedded in the Bitcoin blockchain, and it really can't be gotten rid of, right? It's like a toxic waste dump, and it just keeps getting bigger and bigger. So you take a look at the link at the bottom for more information about this bloat problem. All right, so what the heck are we going to do about this? And this is the last part of the talk, and it'll transition into our discussion. But basically, one solution to some of these problems is what are called consortium or permission blockchains. And sometimes people call these private blockchains. That term, depending on who you talk to, might have a slightly different meaning. I'll explain that in a second. So what the heck is a consortium blockchain? It's basically a blockchain where the consensus process is controlled by a pre-selected set of nodes, rather than just anybody and their dog who wants to connect to the network and participate in the mining process. And that's why we call it a consortium blockchain, because it allows groups of companies to coordinate their interactions with each other. If you take a look at the link at the bottom of this page, the author distinguishes between public blockchains, such as the Bitcoin blockchain, consortium blockchains, which is what we're about to talk about, and private blockchains, where you have a single party that's responsible for reading and writing to the ledger. So we're not as interested in that potentially at this point, although that could be an implementation artifact for what we're trying to do. So the idea is you have a bunch of, say, companies or groups who want to work together. So you can imagine in our context, we have a bunch of suppliers and buyers, and they want to work together in order to be able to provide resources and share what I'm about to talk about. So what the heck goes into a consortium blockchain? Well, it's basically a permissioned peer-to-peer shared database. So you can imagine a bunch of nodes which have replicas of all the data, and all the transactions or blocks of transactions get sent back and forth and stored at all the nodes and processed by all the nodes. And we use a blockchain in order to keep track of those artifacts. So in some sense, a better term from this would be a permissioned peer-to-peer shared database, where the blockchain is simply an implementation artifact. In much the same way that when we talk about a database, we don't talk about the fact that it may be represented as a B tree. We talk about the fact it's a database. We talk about the capabilities it provides, or a transactional database, an SQL database. So that's the high level. In a consortium blockchain, all the blocks are signed by a known set of validators. We don't have miners. We don't have proof of work as we do in the public blockchain. Instead, we have validators, and all the validators are known because it's permissioned. You can't join the consortium unless you're invited to join or you're given access to join. And the way it typically works is, rather than having everybody go out and laboriously compute little mathematical puzzles in order to figure out some magic value in order to get some incentive in the form of some gas or some Bitcoin or whatnot, the validators just take turns signing the blocks. And there's a variety of different schemes here. You can do sort of a strict round-robin model. You can do something called mining diversity, which is done by a company called Multichain, where people can only do it every so often, but it's not strict round-robin to avoid problems if somebody were to crash, which would bring the whole system to a screeching halt. And one of the motivations for taking turns is to prevent any one of the validators from censoring what's happening. The other thing that's provided, of course, with a consortium blockchain, just like with the public blockchain, is fault tolerance and resilience to Byzantine failures. So the system is deliberately resilient to failures or abuse by less than a majority of the nodes. You can also prevent rogue admins from censoring or corrupting the data, because if one of the parties in the consortium decides to go off the reservation and do bad things, the other parties will detect that problem and will outvote them and will keep that from becoming the public record of what's happening, or the consortium record, not the public record, the consortium record of what's happening. And that's important because a lot of the attacks that take place in modern information systems come from insiders, from sysadmins who get pissed off. And so we want to make sure our system is deliberately built to guard against that. Now, this is not to say you can't have problems in consortium blockchains. If you have enough of the actors get together, they can collude and rewrite the chains to do things that are not what actually happened. And in that case, you may need to have legal recourse to rectify the detected abuses. But given that these are companies who are ideally reluctant to do fraudulent things and then get hauled in front of the court and sued, it's easy to detect these problems because everybody has copies of everything that they could monitor. You can make the regulators be simply a node on the blockchain that's just a read-only node. And so if something goes wrong, you can figure it out and address it. Another benefit you get from this approach is control over capacity and costs. Unlike the public blockchains where who the heck knows what's going on and anybody can throw their hat in the ring, and so it's difficult to know how much the transactions will be, how much capacity is out there. In a consortium model, you can scale it up or down based on the workloads and the requirements and the willingness of people to incentivize faster performance by buying additional resources. And there's no need for cryptocurrency as the vehicle for exchange. You could do it through some other means. You don't have to do it through cryptocurrency. All right, so that's kind of a wrap-up of what I wanted to talk about. I think, as we may have talked about in other discussions, no technology is considered to be mature and real until it is mocked in Dilbert. This is actually a modified Dilbert ad where the pointy-haired boss or the modified Dilbert comic, the pointy-haired boss comes to Dilbert and says, "I think we should build a blockchain." And Dilbert gets nervous and he says, "Does he understand what he said, or is it something he saw in a trade magazine ad?" So he asks his boss, "What color do you want that blockchain?" And the boss says, "I think mauve has the most RAM." It's clearly indicating he doesn't know what the heck he's talking about. In a more serious note, Gardner, which creates these hype curves every year, has a hype curve for 2016. I haven't seen 2017's hype curve yet. I'm sure it's not unlike this. And in 2016, they saw blockchain kind of reaching the top of the peak of inflated expectations and about to drop off into the trough of disillusionment. And obviously, these things ebb and flow. And part of the trick is to figure out what kinds of applications blockchain works for and what it doesn't. And that's really part of what we're doing here with this project. So we have other work going on in this space. Professor White, myself, Professor Dubé, Dana, our grad students, other people, Mike Walker and so on, the Blockchain Club, people in town, HashTealth, the Center for Medical Interoperability. There's a lot of work going on around the area on this topic. And of course, our goal is to work together with them and our partners on this project in order to be able to get the most out of what we're trying to do.